Ammeter. An ammeter is a measuring instrument used to measure the electric current in a circuit. Its symbol is represented here. In galvanometer, we can calculate a small amount of current, but for greater amount of current, we need another device, and we can calculate the current from ammeter by the help of ammeter. Galvanometer is a sensitive instrument. A large current cannot be passed through it, as it may damage the coil. A galvanometer can be converted into an ammeter by connecting low resistance in parallel with it. So galvanometer is sensitive device, and it cannot measure the greater amount of current. So we can convert galvanometer into ammeter by connecting a low resistance in parallel with galvanometer. Its circuit diagram is shown here. We connect the low resistance or shunt resistance in parallel with galvanometer. Now this apparatus is converted and it is now known as ammeter. When large current flows in a circuit, only a fraction of a small current passes through the galvanometer, and the remaining larger portion of the current passes through the resistance. When a large current passes through this circuit, so it can follow the path from the shunt resistance, because shunt resistance is low resistance, so it allows current to pass through it. The low resistance connected in parallel is called shunt resistance. This low resistance is called as shunt resistance. Calculation for the shunt resistance. Let Rs represent the shunt resistance, Rg the resistance of galvanometer, Ig the current which produces full scale deflection in the galvanometer. Current passing through circuit is I, and it divides at this point into Ig and I minus Ig. Actually, Ig is the current that is passing through the galvanometer, and remaining current can be calculated by I minus Ig. We can subtract I minus Ig to get the remaining current that will pass through the shunt resistance. Since shunt is connected in parallel to the galvanometer, therefore potential across galvanometer is equals to potential across shunt. Vg is equals to Vs. From Ohm's law, we know that V is equals to IR. So we can write Vg is equals to IgRg and Vs is equals to IsRs. As we know that Is, current passing through shunt resistance, is I minus Ig. Putting the value of Is is equals to I minus Ig, we get IgRg is equals to I minus Ig into Rs. So we get Rs shunt resistance is equals to IgRg divided by I minus Ig. Voltmeter. Voltmeter is an electrical device which is used to measure the potential difference between 2 points. Conversion of galvanometer into voltmeter. A galvanometer can be converted into a voltmeter by connecting high resistance in series with it. Voltmeter is represented by this symbol. And we can convert galvanometer into voltmeter by connecting high resistance RH in series with galvanometer. So this connection gives us voltmeter. The value of this resistance depends upon the range of voltmeter. So by changing this value RH, we can get the voltmeter of different ranges. Suppose a galvanometer has a resistance Rg and current Ig is passing through it of potential Vg across it. So current passing through galvanometer is represented by Ig, resistance of galvanometer is represented by Rg, and the potential across it is represented by Vg. We know that in series combination, current through the galvanometer is same as that due to the resistance. So current passing through this galvanometer Ig is equals to current passing through this resistance RH. So both current will be same. Also in series combination, the total voltage can be determined by V is equals to Vg plus Vh, because Vg is potential of galvanometer and Vh is potential across this high resistance. Vg is equals to IgRg from Ohm's law and Vh is equals to IgRh from Ohm's law. Actually, IH is equals to Ig because current is same in series combination. So we can write Ig into RH. Taking Ig as common, we get V is equals to Ig into Rg plus RH. Ig can be divided by V and we get V divided by Ig is equals to Rg plus RH. We can subtract RH on the second side of the equation and we get RH is equals to V divided by Ig minus Rg. We subtracted Rg on second side of the equation. This equation gives the value of high resistance, which is used to convert the galvanometer into ammeter. In order to increase the range of voltmeter, the value of Rs should be increased. So in this formula, we can calculate RH is equals to V divided by Ig minus Rg. The value of high resistance can be calculated by the help of this formula. We can increase the value of high resistance to increase the range of voltmeter. AVOMETER multimeter. It is an instrument to measure current, voltage and resistance. So it is ammeter, voltmeter and ohm meter. AVO. A for ammeter, V for voltmeter and O for ohm meter. It is a galvanometer having series of combination of resistors all enclosed in a box. So in avometer, series of resistors are connected in such a way that we can get a voltmeter, ammeter and ohm meter in avometer circuit. So we can connect our switch with voltmeter, ammeter or ohm meter. For calculating any quantity, voltage, current or resistance, we can connect the selector switch with that measuring instrument or that measuring connection. We can connect the selector switch with voltmeter connection or ammeter connection or ohm meter connection, and this switch connects the voltmeter or ammeter or ohm meter with the galvanometer to give the required range or quantity which we want to calculate. So this is the practical example of AVOMETER. By the help of AVOMETER, we can calculate current, voltage or resistance, and here we are calculating the desired quantity by the help of AVOMETER. Current measurement. When the selector switch of AVOMETER is connected with current measuring instrument, we can calculate the current through it. Here is the circuit diagram of current measuring instrument in the AVOMETER. We can connect the selector switch with any of the resistance that are connected in series. So when we connect this switch with any of the resistance, we basically connect the shunt resistance in parallel with the galvanometer. So now this circuit is behaving like a ammeter. For selector switch connected with only one resistance, we can have small amount of current through the ammeter circuit, and when we increase the resistances, we can have the larger amount of current passing through the ammeter circuit or current measuring circuit. So this value of resistance gives us different ranges of ammeter. For the measurement of current, the selector switch is turned to X2. The selector switch is turned to current measuring instrument, that is represented by X2. The proper scale is selected. This circuit is a series combination of shunt resistances R1, R2, R3, and combinedly it is called as universal shunt. Any one of the shunts can be used for measurement of current in different ranges. So by changing the values of resistance, we can have different ranges of ammeter. Resistance measurement. Now AVOMETER is connected to the resistance measuring circuit, that is represented by X3. When selector switch is connected with X3, that is current measuring circuit, we can determine or calculate the resistance by the help of this resistance measuring circuit, ohm meter. Now this battery is connected with the galvanometer, and there is a small amount of resistance connected with it. We are providing the voltage to this galvanometer, and current is flowing through this galvanometer. We have an unknown resistance, and by the help of this resistance, the deflection of galvanometer changes. and we can calculate the resistance by the help of this observation. So scale can be converted into resistance. If there is no resistance or zero resistance, then deflection will be maximum, and when the value of resistance will be high, then current flowing through the galvanometer will be reduced. For resistance measurement, the selector switch uses the circuit as shown in figure. The leads are connected across the resistance to be measured here, X and Y. The battery of the meter supplies current to the meter for deflection, in which in turn varies with the external resistance and can be calibrated. So this battery is providing current to this galvanometer, and current flowing through this galvanometer can be changed by the help of this external resistance, and this change and this variation can be observed and calculated as resistance.